Good evening, everyone. This is Veer Maheshwar Charitable Trust Latur MS India organizing daily international webinar series. This series is running from last 5 years. Speakers from India and abroad are invited to join here to deliver their topic as per their expertise. This series is running from last 5 years. The topics from education, law, health, technology, finance, all topics are accepted here, and every day we are enriching in the knowledge by listening the speakers deliver knowledge in the webinar delivered by the various speakers. Today, on 18th July, we have invited Rintu Augustine ma'am, who is Assistant Professor, Department of Computer Science, Computer Applications, Shankara Institute of Engineering and Technology, Kaledi. I welcome you, ma'am, from my organization, from all the participants. And the topic is blockchain in everyday's life, applications, opportunities, and the future. Being a teacher of computer applications, the blockchain in everyday's life, she will explain with her expertise. I welcome you, ma'am, again, and all the participants, those who have joined here. And I request you, you can start your speech now. Thank you. Kindly unmute.
Okay, thank you, sir. Thank you for the warm welcome. Shall I start, sir?
Yes, ma'am. Yes, please.
Am I audible, sir?
Yes, ma'am. Yes.
The screen is visible, right?
Yes, yes.
Okay, sir. Good evening, all. Today's topic is blockchain in everyday life, applications, opportunities, and the future. Why blockchain matters today? The term blockchain is considered as a required literacy topic in emerging curricula. That means every area like bank, governments, hospitals, even the universities are migrating to blockchain technology. According to the survey of Industry Market Forecast 2025-26, $1.9 plus trillion global blockchain market is expected by 2030. That's why blockchain matters today. Actually, blockchain is a part of evolution of digital transaction. The first phase was cash. We know the physical cash. Later, we used cards like ATM cards. The Kanta survey published in Financial Express, 83% of Indians are aware of cryptocurrency. Among those 83%, 16% have crypto ownership also. According to the another report of Statistics and Data, Bitcoin is considered as one of the top 10 cryptocurrency based on the market capitalization. The figure shows clearly the top 15 cryptocurrency by market capitalization. It clearly shows the Bitcoin is the highest one. And this report states that every people are migrating to the Bitcoin or cryptocurrency. And now, what is Bitcoin or what is blockchain? I will give you a simple example demonstrating this idea of blockchain. Imagine in a department, there are many faculty members and we keep one attendance register. And attendance of a faculty member is reported in the attendance register is made by the agreement of all other faculties. That means a copy of attendance register is kept with every faculty member. And if a faculty is present, if everyone agrees that the faculty member is present, that transactions will be done in that register. That means if tomorrow some other faculty secretly changes one register, it won't happen because the remaining registers will immediately reveal that something is wrong. That is the concept of blockchain. It is a shared tamper-proof digital record. That is the concept of blockchain and how the blockchain works. This diagram clearly shows the working of the blockchain. Hope you can see the figure, right? Can anyone reply? Hello? Sir, am I audible? Yes, okay. Okay, the transaction, here the user A and user B, there are two users, user A and user B. Here user A sends some transaction to user B. Let it be transaction 3. When a transaction happens between two users, this transaction is added to the memory pool. Memory pool is an area where the unprocessed transactions are kept. And from the memory pool, there is a specialized node in peer-to-peer network. They are known as miners.
If any disturbance, we will inform you. Don't worry, you can continue. Okay?
Okay, sir. Okay, sir.
Okay, thank you.
I repeat, we have two users, user A and user B, and user A is sending some transaction, let it be transaction 3 to user B, and the transaction is added to the memory pool, and the memory pool is an area where unprocessed transactions are kept. And in the peer-to-peer network, there are specialized nodes known as miners. These miners will select some transactions in chronological order and will form a block. This is an example of block. And the miners will try to solve a puzzle-like problem known as POW. And the miner who succeeds first can attach this block to this blockchain. That is the overall idea of this blockchain. Here in this diagram, we can see a central blockchain. And here the yellow color is known as block 0. That is known as the first block. That is Genesis block. And it is attached with the second block, block 1, attached with the block 2. Similarly, it will incrementally build this blockchain. This is the concept of blockchain. Here is a comparison between the traditional database and the blockchain. The control, the first one is control comparison. In the traditional database, we have a centralized control. In the case of blockchain, it is decentralized. That is, it is in a shared network. Editing records, in traditional database, it can be altered or deleted. But in the case of blockchain, it is immutable once it is confirmed by the peer computers. Next one, trust model. Here, in the case of bank, we trust the bank or institution. Here, they trust the network. Transparency. In the traditional database, there is no transparency. It is private, restricted access. In the case of blockchain, it is shared and verifiable by all the nodes. Then failure point. Single point of failure in the case of traditional database. In the case of blockchain, no single point of failure. Then core features of blockchain are listed here. The first one is decentralization. We already discussed. It is a decentralized nature. There is no single controlling authority. Next one, transparency. The same document is kept by every computers. So it is transparent, shared visibility of transactions. It is immutable. That is, once the records are added, cannot be altered. That is immutable. Then security. To access the data of the first block, you have to start from the last and you can connect to the previous blocks and you can reach the first one. Next one, anatomy of a block. A block here, the first one is, we already discussed, it is a Genesis block. The second one, let it be block 1 and block 2. And the internal structure will be like this. Each blocks will be connected using the hash value. I will discuss the hash value in the next slide. Here the hash value you can see, in a block we have a number of transactions. Using all the transactions, we will create a hash value. That is a summary or an essence of all the transactions is known as a hash value. Here, in the case of block 0, the hash value is 1A71. In the case of block 1, we have a number of transactions and its essence is known as hash 2B81. Here, we keep the previous hash 1A71, that is pointing to the previous block. Similarly, the blocks will be connected to each other. If we make any changes to the transaction in block 1, a simple change, a minor change will also reflect in the hash value. It will change the hash value. If we change the hash value, the connection with the blocks will be lost. In this way, the transparency and the immutability is maintained in blockchain. It shows the anatomy of the block. Each block will have these sections, block header, data. In this data section, it will keep the transactions, hash value. We already discussed hash value is the essence of all these transactions. It can be called as a unique fingerprint, and nonce, that is the number used for proof of work. That is a puzzle-like problem. We use a number, that is nonce. That is the anatomy of the block. Then about the hashing used in the blockchain. It is considered as the digital fingerprint. That is, there is a hash function used in the blockchain. Hash function, we can consider it as a machine, and we can give a number of transactions in a block as an input to the hash function, and it will generate a unique code value, that is the hash value. If we make any of the changes to one of the transaction, it will change the corresponding hash value. Even a tiny change produces a completely different hash, that is known as avalanche effect of the hashing. So this will make the blockchain more secure. Next is consensus mechanism. That is how these blocks are added to the blockchain. In the case of Bitcoin, Bitcoin is considered as the first cryptocurrency. And in the case of Bitcoin, we use proof of work. Proof of work, the miners will try to solve the puzzles, and the person who solved the puzzle first will have the right to add the block to the blockchain. There is another technique or consensus mechanism like proof of stake. It is used in Ethereum. And here, the validators are chosen based on the financial gain. And there is another one based on Byzantine fault tolerance, PBFT also. Here, non-validates vote agreement needs a supermajority. That is Hyperledger fabric. These are the major consensus mechanisms used in blockchain. And next, we are moving to the smart contracts in action. Smart contracts means self-executing digital agreement. That is, this is a digital agreement done based on some conditions, and it is self-executing also. That is, if we set some conditions and those conditions are met, it will automatically execute those instructions, or it will work automatically. I'll give you one example, flight insurance. In the case of flight insurance, for the compensation, and it will take many days for getting the compensation. We have to apply manually or fill out the forms or apply. Then it will take some time to get the compensation. If we use smart contract, it will automatically set. It will automatically track the flight timing and all. If the flight is delayed for 2 hours or more than 2 hours, it will automatically trigger. Yes, the term is trigger. Automatically trigger the code, self-execute, and it will automatically enable the compensation to you. In this way, we can use smart contracts in every field. This is only one example. And there are different types of blockchain. First one, public. Second one, private and consortium. Public blockchain is open to anyone. There is no need to get the approval of anyone. It is fully decentralized. But there is a second type, private. It is restricted to one organization. Restricted to one organization means one organization can keep all their data in their private blockchain. And there is a third type, consortium. It is a combination of both public and private. That is a combination of this private and public. That is, there will be some organizations in a group, and they will have some shared control among the organizations. And their examples are also listed here. Public blockchain. Examples are Bitcoin and Ethereum, and private blockchain. Examples are Internet Enterprise Ledgers Consortium, Banking Trade Consortium, etc. Then blockchain ecosystem. Blockchain ecosystem refers to the components that are necessary for running the blockchain smoothly. The first one is nodes. Nodes are the computers that store the transactions, and they can verify the transactions. The computers in the peer-to-peer network are referred to as nodes. Then next one we have wallets. Wallets are considered as digital purses, not holding the money, holding keys, not physical keys. In cryptography, we have terms like public key and private key. To understand the idea of public key and private key, I will give you one example. Every user will have both keys, private key and public key. Imagine one bank. The bank will be publicly released. That is, everyone can see that public key. But private key will be kept as secret. If I want to send money to that bank, the key of the bank, and he the message, the transaction. And when the bank with the private key, only the person, that means the private key is with the bank, so only the bank can decrypt the message and read the message. That is the concept of public key and private key. The wallets are used in that concept. You can use the wallets for keeping your keys. Then miners. In the case of blockchain, we already discussed about the miners, specialized nodes in the peer-to-peer network, and they are trying to solve the proof of work problem. The miner who wins in solving that puzzle will have the right to add the block to the blockchain. In the case of validators, in proof of stake, the validators are used. The computers with the more financial gain, have the right to add the block to the blockchain. And DApps, this is a short form of decentralized apps. The applications developed in this decentralized form in the blockchain. These are the blockchain ecosystem ideas. And everyday applications we are familiar with are, these are not the blockchain applications. These are using the characteristics or features of the blockchain. In the case of Google Doc, we are familiar with the Google Doc. Google Doc can be opened by multiple persons at a time. We can see what others are doing in the document, and also we can see the updations done. Similarly, in blockchain also, a transaction noted by one person or one computer can be reflected or can be accessed or can be is visible by others also. Then the WhatsApp verification. In WhatsApp verification, when we send a message, we can see a message like end-to-end encryption. Keys are used. Okay, end-to-end encryption is used for sending your message. Similarly, here also encryptions are used. Then Amazon parcel tracking. If we order something via Amazon, we can track its delivery. Similarly, we can also track the path of the transaction or path of the product in blockchain. Digital certificate. Here also we are creating tamper-proof, instantly verifiable credentials used in chain. Then banking and finance. In banking, we know the traditional banking systems. If we want to do cross-border payments, that is from India, if you want to pay some amount to there will be some intermediary heavy settlements or fee transaction fees, etc. So the solution to these problems are introducing blockchain in this sector so that we can directly send from sender to the receiver. We can directly send the money with a lower fees. And real world example is RippleNet. One of the example medication histories are kept with the hospital. Sometimes it is hospital and introducing through this we can diagnosis and drug authenticity. Here the example is Medilet. In supply chain we can use or logistics we can use the city of the goods. If we are purchasing an object or purchasing a product, we can trace its origin through this blockchain where it is cultivated and each stage that product passed through. Here, end-to-end blockchain tracking from origin to consumer is possible. So, reduced fraud, faster recalls, verified ethical sourcing. And here, IBM Food Trust is an example of supply chain. Then, in the case of education, government, and digital identity, also, the blockchains are used. In education, we can use it for certificate verification. Then, in government, keeping land records. Actually, in India, they started using this blockchain for keeping the land records, and we can use for public fund tracking also, and also for keeping digital identity. Here we can decide what all details to be revealed to the third person or the second person. Okay, if you want to reveal only your age, you can reveal only the details. Like that, you can keep the digital identity also here using blockchain. In the case of agriculture, insurance, real estate, in agriculture, farm to fork traceability and transparent fair price payments to the farmers. And in insurance, fraud resistant claims via smart contracts. And in real estate, transparent titles, fractional ownership. We can find the owners of this property easily through this blockchain. And blockchain itself is a strong technology. By incorporating other two strong technologies like AI, artificial intelligence, and IoT, we can make the blockchain more stronger. IoT sensors generate real-time data, and blockchain stores that data immutability and transparency. Then AI analyze the trusted data to predict and optimize. Together, autonomous, verifiable intelligent systems can be built. Then, now blockchain in India. What is the relevance of blockchain in India, or what is the status or progress of blockchain in India? Our government has started an initiative named National Blockchain Framework. This framework is mainly for researchers or the persons who are interested to create blockchain services. Okay, that is National Blockchain Framework proposed by India. Then Digital India. Currently, the Digital India is used by our government to keep land records, certificates, and PDS. Then we have another National Academic Repository for keeping the certificates and all academic credentials. Then RBI has introduced e-rupee, but actually it is under RBI control and not actually related to the cryptocurrency like Bitcoin, but it is similar to that concept of Bitcoin. E-rupee is introduced as a test purpose, and these are the developments in India. And the challenges and limitations of this blockchain are scalability. Here, scalability is one of the main issue with the blockchain, and energy consumption. For doing proof of work networks, proof of work, computationally efficient systems are required. That is another challenge. Then regulatory uncertainty. Many laws are still in India also. There is some limitation for the blockchain because we are under the RBI, and if we are completely moving to the blockchain, it will be a decentralized and no control will be over or the money transfer and all. And there is some regulatory problem in the case of financial service and irreversibility. That is, if a mistake happens, we cannot undo that mistake. That is another problem. Then usability and garbage in, garbage out. Then future trends to watch is Web3, DeFi. These are the future trends of blockchain, CBDS, central bank digital currencies like India's ERP, metaverse, blockchain-based virtual asset ownership, tokenization, fractional ownership of real-world asset, green blockchain, energy efficient, sustainable networks. These are the future trends of blockchain. Okay, by this slide, I'm concluding the basic idea of blockchain. Hope you all got a basic idea of blockchain. Thank you.
Sir, no sound.
And for your studious presentation, what is blockchain, how it works, how AI is implemented in there, what are its limitations, how it is unreversible process. All these things are best represented by you in your presentation. Thank you for your presentation, its applications and the limitations you have also given. I request participant, if you want to discuss our speaker, you can discuss on blockchain in everyday life, applications, opportunities, and the future. Welcome, Dr. Swanand Shukla, sir. Madam, kindly make your camera on. It's a audio, it's not audio event. It's video event.
Good evening, Dr. BETKAR, sir. Good evening, ma'am. Thank you for your wonderful presentation. My question is how we can utilize this in a healthcare system?
Sir, in healthcare system, sir, am I audible?
Yes.
Yes,
Sir,
you
in
are audible, but make the camera on so it gives interactive session. It's not the audio session. Please.
Okay.
Yes,
Sir,
ma'am.
in healthcare
Yes.
sector, the patient's details can be stored in blockchain. Okay. Similarly, in transaction, in financial transaction, we will keep the transactions in blockchain. Similarly, patient details can be kept as details in the blockchain, and
Can it show diagnostic test and because patients are coming for the follow-ups, so it is not one time the entry what data we are filling. So when patient comes again and again after 1 month, 2 months, so can we make that data updated?
Yes, sir. It will be added, not updated to the similar data. It will be entered as a secondary data. Once we add the data to the blockchain, we cannot modify it.
Even diagnostic data like blood sugar level what we are monitoring every time, and we want to record and we learn the trend, whether it is ascending, whether it is descending, or the same thing with the hypertension, whether the blood pressure is rising or whether it is coming down. So we have to keep monitoring these aspects. It is not like once we are giving medication we will forget the patient. So can we find out those things, and can we get feedback also from the system?
The blockchain actually used for storing these informations. So as you said, the blood test and all the details will be stored as a separate entry according to the chronological order. Okay, if we design the smart contract according to some conditions, obviously we can give the output of the output as you require.
To what length of time it can be stored?
Sorry, sir.
To what length of time it can be stored?
Sir, I didn't get you.
To what length of time we can store this?
Length of time. It is not, there's no restriction, sir. We can add as many as blocks to the blockchain.
because when we are saying a paperless world and we don't want to use papers, we are, especially in hospitals, we have to maintain this documentation. Sometimes it is required for patient reference, sometimes it may be required for medical legal cases, sometimes, for our research work. So multiple reasons are there. And we cannot store them more than 10 years because the voluminous papers are there. So I think this will solve the problem. Is there any problems with utilization of this system?
Hospital case, sir, in medical case?
Help, if suppose I'm storing it, so is there any technical problem that may occur? There is a possibility.
The technical problem means it always affect the privacy of the patient if we keep all the details in this blockchain. So it is made as permissioned ledger. That is only with the permission of the patient you can access the data. That is the limitation or challenge with this.
It may disappear or it may, get corrupted or something like that. What happens with the...
No, sir, it won't be corrupted. Once any of the data is corrupted, the corresponding hash value will get damaged and it will make the loss between the connection. So we cannot alter the data in the blockchain.
So it is connected to the cloud or anything else?
Yes, sir, it is maintained.
Yes. Thank you. Thank you very much, ma'am, for your wonderful explanation. And really very technical thing, but it is useful in all sectors. Even farmers can use this, even industrialists can use this, even businessmen can use this. So it is one of the very important thing nowadays, the technology taking us at a higher levels. So thank you very much for your wonderful explanation, because this is something new for me. Thank you.
Thank you, sir.
Thank you, Dr. Sir, for discussing with our speaker on important point of the medical related to medical. Now I request other participants, they can discuss with the speaker, and feedback link is available in the chat box. All are requested to fill the feedback link, please. There is a question in chat box. Ma'am, how can we get free ethers to work? Saket contact deployment was not possible without free ethers. If you read the message, you can answer it, please. Thank you, ma'am, for your studious speech. I think you have technical problem, unable to hear us. Thank you for accepting our invitation and joining here as a speaker. Thank you, and thank you to all participants, those who are joined here. Nambo Nita ma'am, Shankar Basappa, Aditya sir, Chaivir Singh ji, KN Divya sir, and then Rahul Mantri, Dr. Harendra sir, Surya Prakash Vyas sir, Dr. Pratap, Uday Pratap sir. I am thankful to all you for joining today also. Again tomorrow we will meet with another speaker. I am also thankful Dr. Swanand Shukla sir, and thankful to all.
Thank you, sir. Okay, thank you, sir, for giving this opportunity for presenting